Remember in the last video where we basically showed that if we have an angle bisector, it corresponds to bisecting the arc that the original angle makes on the circle. So intersecting the angle bisector with the circle makes two equal arcs. And actually this is true in general, that angles correspond to arcs in a circle. And so if I take a random point on the circle like this one and I construct the same angle that we have before, so this equals this, then the arc that's going to correspond to this angle is going to be the same arc as this arc or this arc. So it's going to have the same length essentially. And so we would have the length of this segment equals the length of this segment equals the length of this segment, because of course these lengths also correspond to the arcs, and the arcs are equal, so the lengths are equal. And we can try to prove this a little bit more formally. So suppose I take two angles inscribed in the circle that are equal, so this angle equals this angle. They're going to correspond to this arc and this arc. Now I'm going to prove that these segments that correspond to the two arcs are equal. So I take the center of the circle and I connect like this. Now we need to prove that the blue segments are equal, given that the green segments are equal because they are radii in the circle. But we know that this angle here corresponds to this arc, and so if we take this angle but with respect to the center, it's going to be twice as large. So this angle here is twice as large as this angle here. And similarly, for the other angle, we know that this angle here, with respect to the center that corresponds to this arc, is twice as large as the angle here that corresponds to the same arc. Denoting them by gamma, we get 2 gamma here and 2 gamma here. And so this triangle is congruent to this triangle, because they have two equal sides, and the angle between the equal sides is equal. And because they're congruent, we can now conclude that the length of the blue segment equals the length of the other blue segment. Now consider this situation in which we have that this segment has the same length as this segment, and we need to prove that the two red dashed lines are parallel. So it's essentially the same idea that we've used before. We take the center of the circle. Now we know that this equals this equals this equals this because these are radii. And so this triangle has exactly the same side lengths as this triangle, and so they are congruent. And because they are congruent, they have the same angles, and so this angle equals this angle. So the angle that corresponds to this arc is the same as the angle that corresponds to this arc. And that's completely normal. After all, these arcs correspond to the same length segment here and here. And so it's normal that these two arcs are the same, so they correspond to the same angle also. Now the only thing left to do is to notice that this angle equals this angle. So these are the angles that correspond to this arc and to this arc, and they're equal, and therefore these two lines are parallel, right? Because this angle equals this angle. And this proof also goes the other way around. If we're given two parallel lines in a circle, then they make a quadrilateral, and this quadrilateral is a trapezoid, of course, because it has parallel sides, but it's also an isosceles trapezoid, and it's where the other two sides, the non-parallel sides, this one and this one, are equal. And that's exactly the case here, because from the parallel lines we have that this angle equals this angle, and now it turns out that this arc and this arc correspond to the same angle here and here, and so the lengths of their corresponding segments are equal. This is the optional problem. It's really easy. We have that this angle here is x, and this angle here is 180 minus x, and all these 6 points lie on the circle, and we need to prove that this line is parallel to this line. And here's the solution. If we connect these 2 points here, we have that this here is a cyclic quadrilateral, and because this angle is 180 minus x, then this angle here must be x, because their sum in a cyclic quadrilateral is 180 degrees. Now that we have an angle x here and an angle x here, one of them points towards this arc or this side, and the other angle points towards this arc or this side. And so this arc and this arc are equal, and this side and this side are also equal. And just a while ago we saw that in this situation where we have a cyclic quadrilateral in which one side equals the other side, then the other two sides must be parallel. And that's it, that's the end of the solution. Alternatively, we could have noticed that we have a cyclic quadrilateral here, this cyclic quadrilateral, and so this angle here equals this angle here, and so we got an x here. And then because this angle is x and this angle is x, then these two lines must be parallel, which is exactly the same logic which we used when we proved the statement a little while ago.